In probability, there's this thing called the normal distribution, which describes many things in the real world. Now, the curve that describes the normal distribution is the bell curve. And the equation that describes the bell curve is e to the minus x squared. And the way we use the normal distribution is we take the area under the bell curve, resulting in taking an integral of e to the minus x squared. But what makes this mathematically interesting is that e to the minus x squared is non-integratable, meaning no matter how hard you try, you cannot take the integral of e to the minus x squared. And so sadly, we have to resort to approximation in order to use the normal distribution. But before we get into approximation, I want to give you guys a big thank you because we just passed 100 subscribers. And at the time I'm recording this, we're at 158. Thank you guys so much for subscribing. Let's get back to approximating.
The method we are going to be using for approximation is going to be the Taylor series, since it makes taking an integral of a function way easier. Now what the Taylor series does to a function is it takes a function and turns it into an infinitely long polynomial, where all the derivatives match up with the original function. Now doing this for e to the minus x squared is quite a hard process, so I will just give you the result. E to the minus x squared is equal to 1 minus x squared plus x to the 4th divided by 2 minus x to the 6th divided by 6th plus x to the 8th divided by 24 and so on. Or written in summation notation, e to the power of minus x squared is equal to the sum from k is equal to 0 to infinity of minus x squared to the power of k divided by k factorial. Now we can take the integral of this. And remember, taking the integral of polynomials is very easy. Just take each term and increase the power by 1, then divide the result by that new power. Now you can do this without expanding the summation expression. Because remember, the integral of a sum is the same as the sum of an integral. And so this expression turns into the integral of e to the minus x squared dx is equal to the sum from k is equal to 0 to infinity of x times minus x squared to the power of k divided by 2 times k plus 1 times k factorial. Now the reason we call this an approximation is because we can't actually sum up all infinitely many terms. And so what we do instead is sum up enough terms and so that the error for the final result is small enough that we don't care. But technically, we solved it. Thanks for watching and please subscribe if you enjoyed this content.